Okay, so here I would like to talk about two very basic concepts of basic quantities of electrical engineering. That's voltage and current, so V and I. Now, in order to do that, I will start from basic physics. So we know what is power, and we know, let's say, what's energy and work. We we need energy to uh, do a work, and energy can be of various form, like light energy, sound energy, solar energy, of course, and then which is light energy anyway, and then electrical energy. When we talk about electrical energy, it's related to charge. Now we can say that in order to define potential or voltage, we can say that if there is a positive charge or certain amount of charges, the work that needs to be done to move charge from that amount of charge from one point to another point is the voltage difference between those 2 points. So let's say this is point A, and let's say there is the charge at this point is q coulombs, and in order to move the positive charge from here to point B, if the work done is W, then we will say the potential of B with respect to A. So whenever we talk about potential or voltage, they are the same. It's about potential difference or voltage difference. So potential of B with respect to A, or potential BA, is equal to W over Q. So W is the work done to move this amount of charge. So if we write in terms of differential, we can write dW over dQ, maybe like that. Often there is a reference point of potential, like we say that's ground or neutral point. So if the potential of this point, that point's potential becomes 0, and if that is 0, the other point's potential or voltage is just that whatever that point is. So let's say VA equals to 0. In that case, if if the work done to move q amount of charge from A to B is W, then we can say VB, because VA is 0 anyway, VB minus VA. So VB is equal to dQ over dW, and that will be the same because the potential of A is 0 anyway. But basically it's the difference, whatever the work done to move the charge from one point to another point is the difference. Potential difference is the work done, basically, or the work done is the potential difference. So that's there. Now let's move on to define current in a conductor. I will keep it simple for the time being. So current through a conductor, inside a conductor, and that is defined by, current is, we know that the movement of charge, it's actually the movement of negative charge electrons, but initially electrons were still not discovered at the time this concept of current was developed. So it was only the positive charge was known. So basically the definition of current was like this, that amount of charge that passed through a cross section of that conductor per unit time. So let's say we have q amount of charge that is passing through a cross section at time t, during time t, then current will be q over t. So q is the amount of charge that passes through a cross section, and the time duration is t. So basically we can say that in terms of differential, we can again say dq over dt. So that is the definition of current. Now if we want to, so we have now voltage and current. Now the other thing I will define from these two is power. We know power is work done per unit time in terms of physics, basic physics, classical physics. So that's, power is work per unit time, or we can write in terms of differential, the work done within a time difference. So this one we can rewrite dW over dQ. I will bring in charge here because I want to describe power in terms of electrical energy, because power can be mechanical energy, other energies, but here we are talking about sound energy, whatever, light energy. But here we are talking about electrical energy, so I will write in terms of charge, electrical charge. So uh, I'm just manipulating the differential here. This is dw over dt. I'm writing this dw over dq and then dq over dt. This is just the mathematical manipulation, writing the differential differentiation like this. So what we get now is dw over dq. If we recall, this is our voltage. So I will just write V for the time being instead of VA over VA VB, just because that's the difference, potential difference. So that's V, and this is dq over dt, this is I, so this is becoming Vi, that is power, voltage times current. And whenever we are talking about, let's go back to potential difference and current thing. So let's say potential of this point is A and potential of this point is B again, and this is the amount of charge that crossing through is dq. So basically VBA equals to the potential difference, and that is the, whenever we are talking about potential of any point, potential will always have to be between 2 points, or potential of one point. When we say it with reference to neutral or ground. So that's whenever we say a potential of any point, because potential is always relative, voltage or potential. I'm uh, substituting the word voltage with potential many times. I have done it here, but they're the same basically. Let's say voltage of any point. When we say just voltage of that point, that means the voltage is with respect to ground. That is very important to remember. So anyway, and then current is the amount of charge that crossed through. So if there was, let's say, Q1 charge here, Q2 charge here, so that would be Q2 minus Q1 in time, let's say T2 minus T1, that will be our current, which is I. So I is equal to dq over dt. Let's not make it too complicated, because this is just a very basic thing, but it's always good to remember that what voltage actually is and what current actually is. So yeah, I just thought of making this video. I am making video after a long time, but I will try to make more regular videos from now on. Thank you.